Welcome to Study Loop.
This is a fairly long question with a lot of components, so let's take it step by step. First, we know our quantity supplied function and our quantity demanded function, so we can set them equal to each other, and then we just solve for P. We get P equals 100. What's our quantity? Well, we plug in our value for P, and we get a quantity. So now we have our equilibrium price and quantity with no taxes. Now let's throw taxes into the mix. We have a new quantity supplied function, and we have a new quantity demanded function. Again, we set those equal to each other, and then we just solve for P. And you'll notice circled are the T components. So the P is 100 minus T over 3. The Q is 200 minus 2T over 3. So unlike before, now the tax is represented in both the price and the quantity. Now we know that tax revenue is just the tax times the quantity. And you recall from before, this was our formula for quantity. So all we need to do is just multiply that formula by a t, and we get 200t minus 2 times t squared over 3. And if you graph the relationship between tax and tax revenue, what do you find? You find that as tax first begins to rise, tax revenue begins to rise as well. Only up until a certain point, though. After that point, what happens? If you continue to increase the tax up to 300, the tax revenue begins trailing off. So that if the tax is zero, tax revenue is also zero. But if the tax is 300, tax revenue is zero again. So somewhere in between here, we have the optimal tax that will yield the most revenue. So we know how to calculate consumer surplus, producer surplus. We just calculated tax revenue. What about deadweight loss? Well, recall that deadweight loss, because our supply and demand are linear, deadweight loss is going to be simply a triangle. The formula for a triangle is 1/2 base times height, and we actually know the base and the height. We have T for the tax, that's the price differential, and the quantity differential is just going to be the quantity in equilibrium minus the quantity in tax. So the quantity in equilibrium minus the quantity in tax is going to be 2t over 3. And we have 1/2 t times 2t over 3, excuse me. And you can simplify that to just t squared over 3. So that's going to be our deadweight loss. Now that we have all that, let's take a tax of 200. We can solve for a quantity of 67, and then our deadweight loss would be 13,333 with a 3 repeating, so we just let that drop. The tax revenue is going to be, again, just the tax times the quantity, and we get 13,400. Now the question is that actually the optimal policy? Well, to find the optimal policy, the easiest way to do that is just take a derivative. So we take our formula from before, 200t minus 2t squared over 3. And when you take that derivative, you get this, 200 minus 4t over 3. And then, of course, you set it equal to 0 because we're trying to solve for t. It simplifies into 4t over 3 equals 200, which further simplifies into t equals 150. And sure enough, if you take this tax and find the new Q and calculate the new tax revenue, you'll find that there is no other T that yields a higher tax revenue. So this tax, a tax of 150, gives us the most tax revenue for the least deadweight loss, and therefore it's the optimal tax level.